Okay, anyone first questions? No? Okay, then I will begin with a question. So, where's my question? Okay, so actually I think somebody asked this earlier, and I will ask again a very similar question about the weight that, Maggie, you used a sandbag, you said, on top of your agar gels. And I believe someone earlier was asking about whether you saw syneresis, like leaking of the liquid out of the gel with the pressure, and how you controlled this, and whether that was something you really had to work out.
Yeah, I used a 2.5 weight on top of the agar gel, and what I was really looking for was just for a light enough weight to keep it in contact with the canvas without any excess liquid seeping out. And the way to overcome this was really making a more rigid gel. The 2.5% gel, it didn't matter. Even if you put even light pressure on it, excess liquid would seep out and press the tidal lines out further. But with the 5% gel, I really didn't notice that. And putting blotted paper as well on top of the agar gel, in between the sandbag and the gel itself, actually really helped to maintain this as well.
Question over there.
Hello, I have a question for, for Madame Sopa. I guess you repeated the experiment several times. I was wondering for the glue bridge, how many times did you repeat the experiments, and if you observed the same behavior after this repeated experimental procedure?
Yes, the experiments were repeated, like I'm doing it. I mean, we have a lot of ratios and adhesives, so like 5 times. And we have several, and not only, I mean, we have in the article, you have 2 models. So model A and B. Model A is not as absorbent as model B. So yes, this is checked.
Hello, Maggie. I was wondering, how often did you replace the agar as it discoloured over that 4 to 8 hours?
Basically, I waited. There's a couple of different markers. I changed the blotting paper every hour just to check it. At first, I started changing the blotting paper about every half hour, and as I got more comfortable with treating the stained region, I waited an hour. And then I would look at the discoloration in the gel and how much it shrank. And as soon as it started to get, it made a huge difference within the first 2 hours. You could see the first treatment absorbed quite a lot, and the gel turned brown right away. And after that, I dried the area, so I put fresh blotter down, no gel, and waited that until it became dry to look at the area again. And then if I had to treat it once again, then I would repeat it. So it just really, unfortunately, it just really depended upon how dark the stain was and how quickly it reacted.
Sure. Hello. Thank you very much for your presentations. They're all really fascinating. My question is about the practicalities of working on these stained canvases. I've done a similar treatment myself, and it was extensive in terms of the testing phase. So I guess my question to both of the people presenting papers on the stained canvases is, how do you envisage moving from getting this treatment from the kind of position where you're doing a very extensive kind of massive research project into a more kind of routine phase? Do you feel that as practitioners, you really have to go through that massive research phase before you can kind of get to grips with this type of treatment. I personally found it quite a complex, process to go through, just bringing together the materials. Obviously, this conference will help. I'd be really interested to hear your thoughts on that.
Myself, I think your question sounds almost like a political question in my case. I mean, that the link between research and treatment depends on countries, really. I don't know if you know about French situation. French conservators are very rarely integrated to museums, institutions. They're mainly independent people, and so their access to research and laboratories is not the same as other countries. In Barnett Newman's case, what was different is that I'm lucky enough to be part of an institution, and I've been helped by laboratories, Richard Wolbers, and as you saw, the process of restoring this painting was a very long one, and it had a very long preliminary phase, which I haven't described completely because I didn't have time enough for that. But I'd like to insist on the fact that in France, this is rarer, because the fact that French conservators are not integrated in institutions and not in a narrow collaboration with laboratories has as an effect that they are very often obliged to work without having this very long process ahead.
A similar question was asked of me this morning when somebody also in private practice asked, well, how do we get access to scientific analysis if we're undertaking such an extensive project, which as a practical conservator myself, we usually have very limited time, especially when private collectors or an exhibition is coming up that puts us under deadlines where we may not have all the time to do research and to make mock-ups. However, I think there's a beauty in conferences like this, because in this case we're bringing all of our case studies and sharing them. In that case, you really give everyone a starting point. You're not starting from scratch. If the more and more we share our own treatments that we do, whether it's in private practice or museum, and I'm sure we've all come across similar situations, and we can use other people's treatments as a springboard for our ideas and hopefully shorten the amount of extensive research that we have to do. So I would say definitely just keep the dialogue open between your colleagues and scientists and museums and yourself, so that we don't have to take such a long time. But I guess, yeah, that's my answer for that one.
It's a very interesting question. Yes, very interesting. Yeah. Thank you for it.
Hi, I have a question. Yeah. Whoops. There. I have a question for Maggie, and I think one of the important issues when dealing with Agus, with cleaning with gels is the points of residues, and you were very careful to look if you could find any traces of residues left in your linen canvas. And my question as an analytical chemist is that how confident are you on the detection limits of FTIR when you're looking at residues that effectively is a polysaccharide on a cellulose base? Did you actually do control samples? Did you look at how low you could go in the detection of these kind of gel residues onto the textiles?
I did keep this one on. Yeah, it is. Okay. I did look at. I did bring my own standards as well to look at FTIR. Especially with GTPA, which was one of my, I think I was the most worried about the chelator leaving residues. I would say further research would need to be done. I think that if it is present, it could be present in such a small quantity that it's just beyond the detection limits of what I used. And I think with anything like this, further research and experimentation needs to be done. I was sort of within as a group, we were within the limits of limited in the amount of time we had to look at it. But I think maybe something like GCMS or further analytical methods that are more precise could give us more confidence in that sort of answering it. It's more of a preliminary answer rather than a hardcore answer.
Hi, thank you all for your talks. I wanted a question for Veronique. I was wondering whether you chose 5-micron length micropowder cellulose for the matching the stain. If you checked with other lengths, or why did you choose? Because in the paper you say that there are a variety of lengths. And I was wondering whether you checked different ones and they had a different visual result.
Actually, I chose, we made different attempts, you see, with different length, and we chose the one which was more suitable just to penetrate a little and give a light, very light brownish color. Because really the retouching part has been very small, very little. It was just a matter of darkening slightly some areas, but obviously on such a painting, above all on this unpainted area, you can't have any thickness, you can't have anything on the surface. You see, it would be visible in raking light. So the only solution is to have a very small powder which does penetrate in the cotton fibers and make them look slightly darker.
Did you rinse the cellulose after calcination?
No, actually it's a technique which has been explained to me by Will Shank, who does use it a lot, actually in the States. And the technique is you calcinate it slightly in order to have different shades.
Mm-hmm. But you rinse it after that with water, or?
No.
Okay.
No.
Thank you.
It's powdery. Actually, the retouching is a very powdery texture.
Thank you.
Hi, thank you very much for your talks. I have a question for Carolina Sopa, which is about whether you don't want some degree of consolidation action as well as your adhesive action. If you've got very porous, brittle, absorbent interfaces, aren't you worried that all you've got is a glue bridge, but you might have more interlaminar separation happening?
Yes, thank you. But that's exactly the point what Richard actually said. So if you know your adhesives, or if you want to have them as a consolidant, now you can choose. As you have an absorbent flake and you want that the and then the consolidant is penetrating into it, then you would then take the sturgeon glue. So now you have the choice. And if you want to have some kind of consolidation of the flake, then it's okay. But in this case, the flake is not brittle, or you wouldn't want actually to consolidate it. So it's not that it's powdery or something. You will only want to have this adhesive layer. And of course, if you do not want this, then you would just change your treatment. So that's how you can. Yeah, I tried to make it controllable. So it depends on what you actually want. I hope this answers your question. I don't know.
Laura, I actually have a question myself. Comment actually. It's come up a few times already. We've been asking the idea of clearance, particularly for the agar gels. And we talk about FTIR and GCMS, and it came up, I think, with this question, if you don't have access to scientific equipment or laboratories. For my own work, I was actually able to do detection of agar residues using both UV visible fluorescence at 365 nanometer wavelength and also using a polysaccharide spot test as described in Odegaard's material characterization spot test book. And even though they were not detectable at FTIR levels, they were not detectable by FTIR, they were in fact fluorescing under UV, and they were detectable with polysaccharide spot tests, so that we do know that it's not completely clear, but they're minute. But there are ways to do detection that don't involve the high tech that we don't all have access to.
I'd like to make a further comment on this quickly. When we talk about residual material, we should also consider, are residual material reactive or stable? Now, agar is completely insoluble in water at room temperature. So I know it will not be affected by moisture. It does not take up moisture. Agar in a solid form is stable for years. Okay, so we don't worry too much about potential small amount of residual material because they are not hygroscopic.
I actually had a question for Carolina. So in your mixture of gelatin and methylcellulose, the fluorescing ones, so you showed how the gelatin remains almost like an emulsion particle inside the mixture. And then after the adhesion has formed and dried, the methylcellulose separates from the gelatin, and one penetrates and one just stays as a bridge. Do you think that this emulsion particle kind of distribution helps encourage that? And if you mix these two components differently and change that emulsion-like system, you would still get this sort of separation?
I don't know if I got the question. I'm sorry.
So in your fluorescence imaging, the gelatin stays as these small, it's not completely mixed, it's actually a separate phase. And then when it's drying, they separate in these layers.
Okay, so it stayed when the MC was 5%, so a very rigid gel. And it stayed also as a part in the wheat starch paste, because it gels, and so it's not having the time, or not, the gel between is too rigid. So if you lower down the rigidity of the gel, then the gelatin has a very high kind of, they want to accumulate, and then they can accumulate. You have to leave them the time. As we always see, actually all the people are saying, I don't like mixtures because they separate. And you see it in a jar, it's like in 5 or 10 minutes it separates the methylcellulose from the gelatin. But it depends on the percentage of the gel. So it's kind of a physical thing. You can have it in, and actually we had also a less penetration of the methylcellulose into the wheat, into the chalk ground when mixed with gelatin, because then the gelatin was holding back also the methylcellulose to penetrate into it. So yes.
Other questions from the audience? We still have some time. If not, I also want to ask Veronique one more question. So you showed how with the silicone solvent it was, you said, a little difficult because the whole canvas would darken and then you would have to work with that in terms of how well you can characterize your cleaning extent. How did you deal with that? Did you have to wait each time for the D4 to evaporate and then evaluate? And
actually, this was a very long process because I've been working on very small surfaces, repeating the action. But before I did that, I first did it on a sample, on a lot of time to make sure, because of course I trust entirely Richard, who was the first one to work on the canvas. but then it needs having a certain amount of confidence in the treatment. But the interest of this method is that it can be really, really progressive, and you get a very light result, and then you go on.
And how long does it take between?
About a month.
Wow. Thank you. Anyone else? Early coffee break? Okay.